Hello and welcome back. This video will be on section 2.6, which is all about combining functions. So the first thing that we'll need to look at for combining functions is the domain of a function. And this is something that we've touched on before, but we really do want to drive this home today. So the domain of a function, if it is not otherwise specified, and I'll explain why I need this clarification. The domain of a function is just the largest set of real numbers for which f of x is real. So we don't want to be plugging in imaginary numbers into a function right now. We don't want the function value to be an imaginary. So for instance, we want to exclude numbers that make you divide by 0. Or we want to exclude numbers that make you take the square root of a negative number. Now, sometimes for a function, it will come and it will tell you exactly what the domain is beforehand. So sometimes a function will say the domain of this function is the numbers between 0 and 3. And if you're told what the domain is, that's what the domain is. If you're not told what the domain is, then we'll just have to figure it out. Let's do some examples. So let's find the domain of this function. So when we plug in x, we get x squared plus 3x minus 17. Well, when we look at this, we can plug any number that we want into x squared. We're allowed to square any real number. We can take any real number times 3. We can add them together. We can subtract 17. Nothing gives us an imaginary number. We're never divided by 0. So here, the domain is simply going to be all real numbers, meaning the entire interval from negative infinity up to positive infinity. So there's no restrictions here. Here, we've got another function g of x, which is going to be 5x divided by x squared minus 49. Here, we could accidentally divide by 0 if the bottom of the fraction is 0. But we're not taking any square roots, so we don't have to be worried about taking the square root of a negative number. So for the moment, I just want to know when is the bottom of this fraction going to be 0? So let's solve this. So I've got my scratch work off to the side. So if I take x squared minus 49, I want to know when is this equal to 0? This is factorable, so this will just be x plus 7 and x minus 7. We've got the nice x squared minus 7 squared. It factors nicely. So when is this equal to 0? When x is negative 7 or when x is equal to 7. So I want, so the domain of this function is going to be all numbers except negative 7 and 7. So here's one way to write this down. If we start at negative infinity, we can include all the numbers up to negative 7. We have to skip negative 7 and move on. And then all the numbers between negative 7 and 7. We've got to skip 7 and keep going. All the numbers from 7 to infinity. So you'll notice that we've got all the numbers up to negative 7, all the numbers in between negative 7 and 7, and then all the numbers bigger than 7, but not negative 7 and 7. And we'll just take their union to mean put these intervals together. Another way to see this, if we've got our number line, maybe here's 0, out here this will be negative 7, and up here this will be 7. So what we'll do, we'll end up putting an open dot at negative 7, and open dot at 7, meaning we want to exclude these, but everything else is included here. So we're allowed to plug any numbers that we want in here, except for 7 and negative 7. The next function we've got, h of x, is the square root of 9x minus 27. We're not dividing by any numbers, but we are taking a square root. So we've got to be a little bit careful. We can't take the square root of a negative number, otherwise we get an imaginary number. And in this instance, we don't want to think about imaginary numbers. So what we want to exclude, so I'll write this over in my scratch work off to the side. we've got 9x minus 27. We don't want this to be negative. So when this is negative, we get an imaginary number. So let's solve this. If I add 27 to both sides, I'll get 9x is less than 27. And if I divide both sides by 9, I'll get x is less than 3. Oops. So this is what we don't want. So we can't plug in numbers that are less than 3, but we can plug in everything else. So what we do want is going to be all the numbers that are greater than or equal to 3. This is what we do want. So I can write this down fairly simply. The interval here is going to be all the numbers from 3, oops, I should be careful, all the numbers from 3 up to infinity. And this is going to be greater than or equal to 3. So I'm going to include 3 with the square bracket. I wrote a parenthesis first, which would not be correct. And again, why should I include 3? Well, if I plug 3 in here, I'll get 27 minus 27. I'll get the square root of 0. And that exists. That's just 0. This last example, again, so now I have a square root on the bottom of a fraction. So what I want is I don't want, what I don't want to happen is I don't want to take the square root of a negative number, but I also don't want to divide by 0. So in my scratch work, what I don't want is 24 minus 3x to be less than 0, because if that's the case, then this will be an imaginary number. I also don't want it to be equal to 0, because if this is equal to 0, I'll be taking 5x and I'll be dividing by the square root of 0, and the square root of 0 is in fact equal to 0. So I don't want this to be less than 0, and I also don't want it to be equal to 0. So let's solve this. If I add 3x to both sides, I'll get 24 is less than or equal to 3x. And if I divide both sides by 3, I'll get 8 is less than or equal to x. Or if we think about it, this will be x is greater than or equal to 8. So this is, again, what we don't want. So what do we want? If x can't be greater than or equal to 8, then x has to be less than 8. So this is what we do want. So our domain is then going to be all numbers less than 8. So all the way from negative infinity up to 8. And we're not going to include 8, so we'll write a parenthesis there. So this is just finding the domain of some functions. Now let's move on to actually combining functions. So we'll look at the algebra of functions. We can add numbers together. We can subtract numbers, we can multiply numbers, we can divide numbers. We can do the same thing with functions, because essentially a function will represent numbers. If you plug in x into a function, you're going to get a number out. So we should be able to add these. So we'll look at 4 new types of functions. If you give me 2 functions, we can add them together. If you give me 2 functions, we can subtract them, multiply them, or divide them. So this works exactly how you would expect. If I want to take this new function, which is going to be f plus g, this is literally just take the 2 functions and add them together. If we want to find the difference of 2 functions, it's just going to be take those 2 functions and subtract them. If we want to take the product of 2 functions, it's again just multiply the 2 functions. And then finally, if you want to divide the 2 functions, it really is just dividing the functions. In this last case, we'll have to be a little bit careful. We don't want to divide by 0. So here we'll have to be a little bit careful when we're finding the domain of this function. So let's do a couple of examples. Here I've got f of x is equal to x minus 5. perfectly valid function. We've got g of x is x squared minus 1, another nice function. And what we can do is we can look at f plus g of x. So we're going to make a new function. So what is this new function? We're going to take f of x and we're going to add g of x to it. So this new function is going to be f of x plus g of x, which we can write down as x minus 5, and we're going to add x squared minus 1. And if we simplify this, this will end up being, we've got a positive x squared, we've got a positive x, minus 5, and a minus 1 will give us minus 6. So this is a new function, and this is what the new function is. X squared minus x, x squared plus x minus 6. We can do the same thing with subtraction. We can take f of x and we can subtract g of x from it. This will be x minus 5 minus x squared minus 1. I'm going to distribute the negative sign first, just to make things easier. So this will be x minus 5 minus x squared minus minus 1 is plus 1. So ultimately we've got negative x squared plus x minus 4. So here's our brand new function. We can multiply the functions. And again, this is as simple as just taking the two functions and multiplying them together. And the first function was x minus 5. The second function was x squared minus 1. And we can multiply these. I will FOIL this. So we'll take the first two terms and multiply them. So x times x squared is x to the third. The outside terms, x times negative 1. The inside terms, negative 5 times x squared. And the last two terms. And to put this into standard form, I'll just write them in decreasing order. So we'll have the x to the third term. I'll write the x squared term, the x term, and then the constant term, just to make it look nice. So again, we can multiply functions and come up with new functions. The last one, we can divide functions. I can take f of x and I can divide it by g of x, and what we'll get will be x minus 5 divided by x squared minus 1. And this doesn't simplify really. We can factor the bottom out. We've got an x squared minus 1 squared, so this becomes x plus 1 and x minus 1. But for the purposes of this question, if all we're doing is writing down the function, this is as simple as we can make it. Maybe this is a little bit easier, maybe it's harder. Either of these, I think, are pretty straightforward.